Even if you make your own outdoor power supply, you still need to ensure the stability of the system. Last video showed the assembly process. This video to test its full load temperature and real power. This time I use thermal imaging to test the overall temperature change. The test time is 30 minutes. Turn on the load and start the clock. The load is an induction cooker. The power of the load is about 2,200 watts. The output of the inverter is 115 watts. The output of the battery side is 200 watts. Because the power supply is a 12-volt system to be converted to 220 volts. Then simple calculation. Now the conversion efficiency reaches more than 90% of the Coulomb machine shows the remaining battery power voltage, current power, including the remaining use of time. This power has not yet been calibrated, so not quite accurate for the time being, only as a reference. Next, let's take a look at the 12-volt system under a high current of 178. A temperature change now has been running for 8 minutes. Let's take a look at the overall temperature warming here. Let's take a look at the overall temperature rise here. Thermal imaging data. To give you an explanation to facilitate later comparison, P1 in the upper left corner corresponds to the temperature of the inverter shell. P2 is the temperature of the inverter cooling fan outlet. P3 corresponds to the temperature of the 45 square wire, and the maximum and minimum temperatures can be seen in the box shown.